This is my geometry course. Today we're going to study angles formed by transversals. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now let's first talk about what a transversal is. This line here is a transversal. A transversal is a line that goes through two or more other lines. Now, as I said, we're going to study the angles formed by transversals. So you see all these angles? 1, 2, 3, 4, 5, 6, 7, 8. We're going to study those angles. And what we're going to do is we're going to come up with angle pairs, and we're going to show that in certain situations, angle pairs are congruent, or the two angles in the pairs are congruent, or the two angles in the pairs are supplementary. But in order to do that, we have to come up with names for the angle pairs. And to do that, we have to name the regions. So you see the purple regions are called exterior regions because the purple part is outside of the two lines that the transversal cuts or goes through. You're going to hear the phrase or the verb cut. That just means that the transversal goes through them. And of course, this is the interior region because it's between the two lines that the transversal cuts. So that's important. You might want to take a screenshot of that. Now, we're not going to name these two angles here because those are just adjacent angles. We've already studied those, and we're not going to name vertical angles. We already named those. But we are going to name these angle pairs. These are all corresponding angles. Now, we're going to look at the intersection points. Now, we have an intersection point here, right here, and we have intersection here. Now, if you look at this intersection region here, notice that there are four angles. Again, there's an angle here, 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 and number 6. So notice that number 6 in that region is the upper right angle. This is the upper right angle. But now if you go down to this region where there's also four angles formed by the transversal, number 5 is also in the upper right. So because they're both in the upper right area in relation to the intersection points, these are called corresponding angles. And you have lower left angles are also corresponding angles. And you have upper left angles are corresponding angles. And you have lower right angles. Those are all corresponding angles. Now you're probably thinking, why do we care about this? Why are we coming up with these names? Well, as we go on, you're going to see that again we're going to prove that certain angles and certain pairs are congruent or supplementary. So we're going to need to name these. Now these angles are called alternate exterior angles. Now they're exterior angles because they're on the outsides. This is the inside. Remember, this is the interior, and these are the exterior parts because they're outside the two lines cut by the transversal. So that's what exterior means. They're on the outsides of those two lines. But they're called alternate because one is to the left of the transversal. Now again, this is the transversal here. One angle is to the left of the transversal, and the other is to the right. So they're on opposite sides, so that's what the word alternate refers to. So you have alternate exterior angles here, and you also have an example of alternate exterior here. Again, these are exterior, and we have 15 on the right of the transversal and 16 on the left. So they're alternate exterior angles. There's also alternate interior angles. So these are on the exterior, they're on the outsides of the two lines, but these are on the interior of the two lines. So those are called interior angles, and they're alternate because 17 is on the left of the transversal, and 18 is to the right of the transversal. And there are two possible pairs that are called alternate interior angles. You see we have this pair and then this pair. They're also alternate interior. So again, you have the interior. This is the exterior out here. Then you have the interior. and they're on opposite sides of the transversal, to the left of the transversal, to the right of the transversal. These are very important terms that we're learning here. And then we have consecutive interior angles, and I'm going to give you a screenshot of these so you don't have to memorize them all at once. These are interior. They're both on the inside of those two lines cut by the transversal, but they're on the same side of the transversal. They're both on the right of the transversal. So because they're both on the right of the transversal, they're called consecutive angles. And these are both to the left, so they're called consecutive, and of course they're interior, so consecutive interior angles. So at this point, I want you to take a screenshot of all that stuff that we just learned, because you're going to need to use this screenshot in the next problems we're going to do. Alright, so we're going to name the angle pairs for practice. So these angles, this is the inside part, the part between the two lines that are cut by the transversal. So this is the interior. So the angles you can see are on the exterior, and one's on the top of the transversal and the other's below the transversal. So they're alternate. Actually, I'm just going to abbreviate that. Well, I guess I can. Alternate exterior angles. Now we have two angles that are both on the upper left. Upper left, upper left. Those are corresponding angles. So do you get the picture here? These are on the interior. So they're interior angles, and they're on the same side of the transversal. They're both on top of the transversal. So those are consecutive interior angles. So again, we're just naming the angle pairs. And if you didn't get a screenshot, do that now. You can't do these problems unless you have a screenshot. So now I want you to try. Name the angle pair for number 4. When you come back, we'll do it together. All right, we're back. They're both on the inside of the two lines cut by the transversal, and they're on opposite sides of the transversal. One's on the left, one's on the right. So those are alternate interior alternate interior angles. So if you got alternate interior angles, good job. Now number 5 is kind of a tricky one, because number 5, that's those are angles that we already learned previously. Those are just vertical angles. We didn't have to learn anything new for that one, because you have two lines intersecting, and angles opposite each other are congruent. Well, we don't really care if they're congruent at this point, but we just know they're called vertical angles. All right, now try number 6. Again, you should have that screenshot right in front of you. If you don't have that screenshot, take that screenshot quickly and use that to help you do number 6. So name the angle pair for number 6. What is it? What are these angles called? When you come back, we'll do it together. All right, we're back. These two angles are on the interior of the lines cut by the transversal, and they're on the both on the right side of the transversal. So those are consecutive interior angles. All right, number 7 is kind of a weird one. These angles are just they're adjacent angles. So we just say adjacent angles. There's nothing new there. We already learned about adjacent angles. All right, try number 8, and when you come back, we'll do it together. All right, we're back. So these are both on the interior. They're on the interior of the two lines cut by the transversal. This would be the exterior. So they're interior angles, and they're on the same side of the transversal. They're both below the transversal. So those are consecutive interior angles. So if you got consecutive interior angles, good job. All right, try number 9. You should have that screenshot right in front of you. Name the angle pair. And when you come back, we'll do it together. All right, we're back. These are both on the lower left of the intersection points. So they are corresponding angles. So if you got corresponding angles, good job. All right, try number 10, and when you come back, we'll do it together. All right, we're back. They're both on the interior, and they're alternate because one is on top of the transversal, the other is on the bottom. Again, this is the transversal. So these are alternate interior angles. So if you got alternate interior angles, good job. Try number 11, and when you come back, we'll do it together. All right, we're back. These are vertical angles. Try number, so if you got vertical angles, good job. Try number 12. When you come back, we'll do it together. All right, we're back. These are on the outside of the two lines cut by the transversal. And one is above the transversal, and the other is below the transversal. So they're alternate exterior angles. So if you got alternate exterior angles, good job. All right. So now we're going to go to a special case of this situation, this scenario. You can see we have a transversal through two lines, just like the previous problems that we did. But there's something different about this. This is a more specific case. These two lines, this line here and this line, are both parallel. And we notate the parallel. We know that they're parallel because of these arrows. Now you're probably thinking, well, wait a second, we have arrows here. Well, that's true, but these arrows that show that the lines are parallel, they're a different style of arrow. So that arrow means that they're parallel. The two arrows mean they're parallel. And when two lines are cut, or two parallel lines are cut by a transversal, it turns out the corresponding angles, the green angles, are congruent. And the blue angles are also congruent. And the orange angles are congruent, and so on and so forth. All corresponding angles are congruent if a transversal cuts parallel lines. Now that's a postulate. So how do we know that that's true? Well, there's no explanation needed. It's just true because it's true. Remember, a postulate doesn't need to be proven. So let's demonstrate this. We have two parallel lines, and how do I know that those are parallel? I know they're parallel because of these arrows. So now what we can do is we can find all these other angles, just given one of the angles. We know that upper left angle is 100 degrees. And what we're going to do is find all the other angles. So let's start out with the corresponding angles postulate. So because these two lines are parallel, and this only works if these two lines are parallel. Because those two lines are parallel, this angle must be 100 degrees. Because it's the corresponding angle of 100. 100 is upper left, so the upper left angle must also be 100 degrees. And now we know that this angle is 100 degrees because vertical angles, we know that vertical angles must be congruent. We also know that this angle must be 100 degrees. So that was just information we learned in previous classes, that vertical angles must be congruent. And we also know that this angle and this angle form a linear pair, or we could also use this angle and this angle, it doesn't really matter. Or we can use this angle and this angle, or we can use this angle and this angle. They all form linear pairs, but let's just keep it simple. Let's use these two angles. Because they form a linear pair, by the linear pair postulate, they must add up to 180. They must be supplementary. So obviously this angle must be 180 degrees. You just take 180 and subtract 100, and that gives you this angle. So now that we've got that angle, we know this angle is across from it. They're vertical angles, so that must be 80 degrees. Again, these are vertical angles. And by the same logic, we know that this angle is 80 and this angle is 80, so on and so forth, because these form a linear pair. So again, as you can see, if we have this situation where we have a transversal cutting two parallel lines, all we need is one angle, and we can find all the other angles. So let's do a couple more of those to demonstrate. So this angle, we can start off by saying, well, we know this is 95 because they're vertical angles. We also know that the corresponding angle for this one is 95 because they're both upper right. And this is lower left, so by the corresponding angles postulate, this must be 95 also. Or we could just use the vertical angles theorem. Now, choosing any two angle pairs here, let's choose these two. We know that they're a linear pair, so this angle must be 85 because 180, they must add up to 180. Or you can do 180 minus 95 is 85. So you can get your calculator out if you want to do that. 180 minus 95 is 85. And 85 here and 85 here, those are vertical angles. And same logic down here. So let's do one more of these. This angle is 60 degrees because they're vertical. And then you've got corresponding angles. Lower left, upper right. And linear pair postulate, these angles must add up to 180, so 180 minus 60 is 120. And 120, that's a vertical angle. Same logic down here. So there's no tricks here. This stuff is pretty easy. So now I want you to try some of those problems. Given this one angle, and assuming, again, we have to assume that these lines are parallel. All right. Well, we know that they're parallel by that arrow, but this doesn't work unless these lines are parallel. Now, I want to specify what I mean. The corresponding angle postulate doesn't work. This angle is going to be 130 no matter what. It doesn't matter if they're parallel or not. And this angle must be, these two angles must add up to 180 degrees. It doesn't matter if they're parallel. But when you go from here to here, now it matters that they're parallel. You can't make a relation between these angles here and here unless you know that the lines are parallel. So I just want to make sure that's clear. So go ahead and try number 16, and when you come back, we'll do it together. All right, we're back. Vertical angles theorem, that's 130. Linear pair postulate, this is 50. Vertical angles, this is 50. Now we use the corresponding angles postulate. So those angles are just the same as these. And there you go. So if you got those numbers, good job. I'm going to try to write more legibly next time. So now try number 17, and when you come back, we'll do it together. All right, we're back. 110 degrees, vertical angles, linear pair postulate. We got 70 degrees, vertical angles, 70 degrees. And now we use the corresponding angles postulate. Because these two lines are parallel, corresponding angles must be congruent. So there you go. So if you got those answers, good job. All right, try number 18, find all those angles, and when you come back, we'll do it together. All right, we're back. So vertical angles theorem, angles across from each other are congruent. Then we have to use the linear pair postulate. These two angles form a linear pair. 180 minus 65 is 115. And vertical angles, 115. These are vertical angles. And the corresponding angles postulate says that if those two lines are parallel, then corresponding angles must be congruent. So if you got that answer, good job. Now, I want you to notice something about these angles. Let's look at the last one you just did. Notice that this angle here is equal to this angle in every single case. Those are both called, remember, we just learned those are called alternate exterior angles. Because one angle is, well, they're both on the outside of the two lines cut by the transversal. And one angle is above the transversal. This is the transversal. One angle is above and one is below. So they're called alternate exterior angles. Notice that alternate exterior angles are always congruent. The pink angles are both 115. Also, these angles are both 65. Those are alternate exterior angles. So because of the corresponding angles postulate, we know that those alternate exterior angles must always be congruent. But now we're going to do a formal proof of that. Number 19 says, use the corresponding angles postulate in a two-column proof to show that if two lines cut by a transversal are parallel, then alternate exterior angles are congruent. So I have the picture for us here. We're going to prove that angle 1 is equal to angle 3 because those are alternate exterior angles. This is the exterior. They're exterior and they're on either sides of the transversal. So we're going to show the measure of angle 1 is equal to the measure of angle 3. And that's going to prove that alternate exterior angles are always equal. Now, we're going to use, like I said, we're going to use the corresponding angles postulate. You need to use that postulate. And you also need to use the vertical angles theorem. Those are the two things that you're going to use to prove this. And also, I want you to know that I'm going to go ahead and give you the information. These lines are named A and B, so we're starting out. The given information is that A is parallel to B. Now, you haven't seen this before. You've seen notation A is perpendicular to B. You've seen that, but you've not seen shorthand notation for parallel. So that's what parallel means. It's very simple notation. So that's the given information. We're assuming that A and B are parallel. This doesn't work unless lines A and lines B are parallel. There's another important thing I want you to know, and that is that when you get into proofs later on in this course, sometimes you're not required to show every single step. When it comes to congruency, for example, this statement is asking you to prove that if two lines are parallel and they're cut by a transversal, then alternate exterior angles are congruent. But we're not going to prove they're congruent. We're just going to show that the measures are equal, and then we're just going to assume that you understand they're congruent. So when you get into these more advanced proofs, again, you might see some steps skipped in a lot of textbooks. That's just normal. So we're assuming that A is parallel to B. The two lines are parallel. Now, I know that the measure of angle 3 is equal to the measure of angle 2 by the corresponding angles postulate. So this angle is equal to this angle by the corresponding angles postulate, because this is lower right and this is lower right. So they must be equal because these two lines are parallel. That's the corresponding angles postulate. Now, I also know that the measure of angle 1 is equal to the measure of angle 2, and that is the vertical angles theorem, because these are right across from each other. They must be congruent. And you can probably see where I'm going with this. If angle 3 and angle 1 are both equal to the same angle, that means they must be equal to each other. So the measure of angle 1 is equal to the measure of angle 3. and that is the transitive property of equality. And again, we're supposed to show that the measure of angle 1 is congruent to the measure of angle 3, but you don't have to do that. We're at the point where we can skip some steps because it's just going to get too tedious if we have to show all that congruency stuff. So showing that the measure of angle 1 is equal to the measure of angle 3 is good enough. Because we showed that alternate exterior angles are congruent. All right, so that statement is a theorem. You can see here, that's a theorem because we had to prove it. The corresponding angles postulate, and you might want to get a screenshot of that. That first postulate that we learned that allowed us to do all these problems, that first postulate, that was not a theorem. That's just something we accept to be true. You might want to take a screenshot of that. But we just proved a theorem. Alternate exterior angles are congruent. So you might want to take a screenshot of that. Now, there are some other theorems that we're going to prove. There's two more theorems that we're going to prove. There's another theorem that says that alternate interior angles are congruent. You're going to prove that theorem. And again, you're going to use the corresponding angles postulate, and you're going to use the vertical angles theorem. Now I'm going to get you started with the first step. We're going to assume that line L is parallel to line M, that is given information. That's what we're assuming. And I want you to, again, you're going to use the vertical angles postulate and the corresponding angles postulate and the vertical angles theorem. So try number 20. And again, you can skip some steps. You don't have to show all the congruency stuff. Just show that the measure of angle 1, because these are interior angles. This is interior because it's between the two lines cut by the transversal. And this angle is above the transversal. That's the transversal. And this angle is below, so they're called alternate interior angles. You're going to prove that angle 3 is congruent or equal to angle 1, but you don't have to show congruency. Just show that measure of angle 1 is equal to measure of angle 3, and when you come back, we'll do it together. All right, we're back. So we know that the measure of angle 1 is equal to the measure of angle 2 by the corresponding angles postulate, because those are both lower left. Lower right, lower right, lower right. And because these two lines are parallel by the corresponding angles postulate, those must be equal. Those measures must be equal. Now again, we're going to use the vertical angles theorem. We know the measure of angle 3 is equal to the measure of angle 2. We learned that in a previous class, vertical angles theorem. And you can see what we're doing here. The angle 1 and angle 3 are both equal to angle 2, so they must be equal to themselves. And that is the transitive property of equality. So again, we're supposed to prove that angle 1 is congruent to angle 3, but you can skip a step. You can skip all that congruency stuff at this point because it's going to get tedious if you have to show all that stuff. So we proved that 1 is equal to 3, which proves the alternate interior angles theorem. Alternate interior angles are congruent if the lines cut by the transversal are parallel. Now again, this only works if the lines are parallel. We know that they're parallel because of these little arrows here. So you don't really have to get a screenshot of that. I'm going to show you a screenshot of these later on. But you can see we have alternate interior angles. We have these angles, the blue ones. They're alternate interior angles, so they're congruent. But we also have the green ones. So they're congruent. And same thing with the exterior angles theorem. There's two pairs that are congruent. There's the blue ones. They're alternate exterior. And the green ones are also alternate exterior. They're congruent also. All right, so now, if you got that answer, good job. Now we're going to prove a slightly more difficult, or the next proof is going to be a little more difficult. It says here, use the corresponding angles postulate and the linear pair postulate in a two-column proof to show that if two lines cut by a transversal are parallel, then consecutive interior angles are congruent. Actually, that shouldn't be congruent. I'm sorry about that. That should be supplementary. So angle 1 and angle 3, they should add up to 180 degrees. They should be supplementary. Again, if you look at these angles, consecutive interior angles, they always add up to 180. 65 plus 115 is 180. And same thing here, 65 plus 115 is 180. So it turns out that those consecutive interior angles, they're always supplementary angles. So again, I'm gonna start you off with the first step here, or maybe you can remember what is the given information for this. What are we assuming to be true? Well, we're assuming that F is parallel to G. So remember, you have to use that parallel notation. That's given. And remember, well, in this case, you're probably going to have to show congruency, but go ahead and try number 21. When you come back, we'll do it together. All right, we're back. Now, the measure of angle 1 is equal to the measure of angle 2. That is the corresponding angles postulate. 1 and 2 are corresponding angles because 1 is upper right and 2 is upper right also. Now, angle 3 and angle 2 well, actually they form a linear pair. And we know that just by looking at the diagram. Now, according to the linear pair postulate, angle 3 and angle 2 must be supplementary. And that is the linear pair postulate. So by definition, the measure of angle 3 and the measure of angle 2, they add up to 180 degrees. And that is just the definition of supplementary angles. Now, we're going to take this equation and we're going to rewrite it here, but instead of writing angle 2 or measure of angle 2, we're going to plug in measure of angle 1, because we know that the measure of angle 1 is equal to the measure of angle 2, and that is substitution. So angle 3 and angle 1 are supplementary angles, and that's just the definition of supplementary angles. So we know angle 3 and angle 1 are supplementary, so we proved that if a transversal cuts through two parallel lines, then consecutive interior angles are supplementary. So if you got that answer, Good job. That was a harder proof than the previous two. So again, that's the consecutive interior angles theorem. These are interior angles because they're between the two lines cut by the transversal. And they're consecutive, meaning they're on the same side. The blues are on the right of the transversal, and the greens are on the left of the transversal. So the blues are supplementary, and the greens are supplementary. The blues add up to 180, and the greens add up to 180. So just to review here, we learned one postulate, the corresponding angles postulate, and three theorems: the alternate exterior angles theorem, the alternate interior angles theorem, and the consecutive interior angles theorem. Those are the four things that you have to know for this class, the primary things. So I'm going to give you a screenshot of all those theorems, and what you're going to do is you're going to use those theorems now to find the variables, or the one variable x, in these next problems. So it says, find x and state the theorem and or postulates used. You don't have to do a complete proof. So you don't have to do a formal two-column proof here. In many problems in geometry, you don't have to do a formal proof because it would just get really tedious if you had to do that for every problem. We're just going to state the primary reason for our equations. Now, I know that 2x is equal to 3x minus 70. How do I know that? Well, first of all, these are parallel lines cut by a transversal. So we proved with the alternate exterior angles theorem that these two angles, because they're alternate exterior, they must be equal. So I'm just going to set 2x equal to 3x minus 70. And I need to give the theorem that we used. And I'm just going to abbreviate alternate exterior angle theorem. So at that point, we just have to solve the equation. I'm going to subtract 2x from both sides. And then I'm going to add 70 to both sides. And we get x is equal to 70. So these are our two answers. We had to show the justification, and we had to actually find x. So that's how you do these particular problems. All right, number 23. Look on your screenshot. You have one postulate and three theorems. So do we use the postulate? Do we use one of the theorems? What do we do here? Well, these are consecutive interior angles because they're above the transversal on number 23. They're above the transversal, and they're in between the two parallel lines. So above the transversal means consecutive, and between the two parallel lines means interior. So they're consecutive interior angles. And we know that by that theorem, those angles must add up to 180. That is the consecutive interior angles theorem. And again, when you do these problems, I want you to abbreviate for the justification. So now we just have to solve. Subtract 105 from both sides, and we get x is equal to 75. So very simple. All right, so you should have that screenshot right in front of you. You're going to use one of those four things that we learned. You're either going to use the corresponding angles postulate, or you're going to use one of those three theorems. So try number 24. And again, you have to give that theorem or that postulate you used. And when you come back, we'll do it together. All right, we're back. These angles are both lower left angles. That means they're corresponding angles. So by the corresponding angles postulate, those two angles must be equal, or the measures must be equal. And I'm going to say CAP. That's the justification, corresponding angles postulate. So that's part of our answer, so I'm going to rectangle that. Then we just add add x to both sides. Subtract 65 from both sides. And divide both sides by 2, and we get x is equal to 80. So if you got 80 and CAP for corresponding angles postulate. Good job. Again, you can abbreviate. All right, try number 25. Figure out what x is and give the justification. Give the postulate or theorem that you used. And when you come back, we'll do it together. All right, we're back. So I know that 100 degrees must be equal to 2x minus 10 because these are corresponding angles. They're upper left and upper left. And again, this only works if these two lines are parallel. The corresponding angles postulate doesn't work unless the lines are parallel. So anyway, that's CAP, corresponding angles postulate. Add 10 to both sides, divide both sides by 2, and x is equal to 55. So if you got 55 in the corresponding angles postulate, good job. All right, let's see here. Forgot to write degrees there. Number 26. Now for number 26, you need to be aware, this box here, what does that mean? See that box there? We learned in the previous class that that box means this angle is 90 degrees. That's a right angle. So you have to know that in order to do number 26. So again, you should have your screenshot of that postulate and those three theorems. Do number 26, find x, and give the justification for it. When you come back, we'll do it together. All right, I know that these angles, 7x plus 20 and 90 must be equal. This angle is equal to this angle because they're alternate interior angles. They're on the interior, they're in the middle of the two parallel lines. That means they're interior. And one angle is on the bottom of the transversal and the other is on the top. So they're alternate interior angles. So alternate interior angles theorem. So now all I have to do is just solve that equation. Subtract 20 from both sides, divide both sides by 7, and you get 10. So if you got 10 in the alternate interior angles theorem, good job. All right, try number 27, and when you come back, we'll do it together. All right, we're back. This angle is on the upper right, and this angle is on the upper right in reference to the intersection points. So they're corresponding angles. So I know 135 must be equal to 5x minus 65, corresponding angles postulate. All right, so we're going to add 65 to both sides, and we get, looks like 200. And divide both sides by 5, and we get 40. So x is equal to 40 by the corresponding angles postulate. So if you got those answers, good job. All right, so now we have a little slightly unusual situation because these angles, they're just adjacent angles and they form a linear pair. So we know that by the linear pair postulate, those angles are supplementary. So we can just go ahead and add them up. They should equal 180, and that is the linear pair postulate. So we don't really need the information. We don't really care that these lines are parallel in this case. We don't need that to find x. So this is not anything new. This is what we learned in the last classes. I just want you to be aware there's a difference between what we learned in the last classes with lines intersecting and what we're learning today, which refers to the relation between these angles and the two intersection points. Now, in this situation, we're not going to add or subtract or multiply or divide both sides of the equation. The first thing we're going to do is simplify, because we can simplify this side of the equation. 1x plus 6x is 7x. Then we're going to subtract 5 from both sides. And then we're going to divide both sides by 7. And we get 25. So we did that one together. That was an unusual situation because, again, we don't need one of those, one of the postulates that we learned today, or the theorems. We learned a postulate we learned in previous, or we used a postulate we used in previous classes. All right, so 29, you can do that one. Go ahead and attempt number 29, and when you come back, we'll do it together. All right, we're back. I know that if you add these two angles, their sum must be 180. Now, how did I know that? Well, because these two lines are parallel, and these two angles are consecutive interior angles. They're both below the transversal, so they're consecutive, and they're between the two parallel lines, which means they're interior, consecutive interior angles. By the consecutive interior angles theorem, we know that they have to add, they have to be supplementary angles. They have to add up to 180. So now we're going to simplify. 11x plus 10x is 21x, and 7 plus 5 is 12. And we're going to subtract 12 from both sides. You get 168. And we're going to divide both sides by 21, and we get 8. So if you got 8 and the consecutive interior angle theorem, good job. All right, on to number 30. Attempt number 30, and when you come back, we'll do it together. All right, we're back. These are exterior angles because they're on the outsides of the two lines cut by the transversal. And one is on the right of the transversal. This is the transversal, and one is on the left. So that's alternate. They're alternate exterior angles. So we know by the alternate exterior angle theorem that those angles must be congruent, or the measures must be equal if you want to be technically consistent. And that is the alternate exterior angles theorem. So now we're going to subtract 3x from both sides. Then we're going to add 38 to both sides. Divide both sides by 2, and you get 30. And by the way, we're not showing the justification for all these algebraic steps because, again, this is not a formal proof. Like I said, if you try to do a formal proof every time you do anything in a geometry course, it would get really tedious. All right, so if you got those two answers, good job. So now number 31 is a little weird because we're not using anything that we learned today. These are just vertical angles. This is all stuff that we learned in previous classes. So I know that 186 minus x must be equal to x plus 10 because of the vertical angles theorem. You can just abbreviate there. Add x to both sides, and we get 186 is equal to 2x plus 10. Subtract 10 from both sides, you get 176 is equal to 2x. Divide both sides by 2, and we get x is equal to whatever that would be. I'm going to get out my calculator. 176 divided by 2 is 88. So if you got, well, we did that one together. So again, some of these problems, you're not going to need the information that you learned today. You're just going to use the information you learned in previous classes. Now, there's another situation that I want you to be aware of here. You might see these types of problems in geometry textbooks. These angles, we can use a very easy argument to show that these angles are supplementary. But those are not, that's not an angle pair that we came up with a name for. For some reason, geometry textbooks, they only use the angle pairs that we already mentioned. So these angles would technically be consecutive exterior angles. But geometry textbooks just don't have a theorem for that for some reason. So, so just be aware of that. But I want you to know that we can still figure this out. Obviously, if these two lines are parallel, then this angle must be 40, because this angle and this angle are both bottom right angles in reference to the intersection points. So because this angle is 40 here, and these two angles form a linear pair, that means that 40 and 3x plus 20 must be supplementary angles. So we can just add them up. They add up to 180 degrees. And there's no special postulate or theorem that we're going to use for that. So actually we should say NA, not available. So now we're going to simplify. 20 plus 40 is 60. Subtract 60 from both sides, we get 120. Divide both sides by 3, and we get 40. So x is equal to 40. And not available, I want that to be part of your solution for some of these. All right, so number 33, we have alternate angles because one's above the transversal and one's below the transversal. They're alternate. But one of them is in the interior and the other one is in the exterior. So we don't really have a special name for this pair. But that doesn't mean we can't figure it out. That doesn't mean we can't figure out what x is. Let's see here. Well, we know that this angle must be 125 by the vertical angles theorem. And we know by the consecutive interior angles theorem that this angle and this angle must be supplementary. They must add up to 180 degrees. So 125 plus 3x minus 5 is equal to 180 degrees. And the justification for that is not really available. We don't have a special name for that. Now, again, we could prove all that with a formal proof. But because this proof is not available, we're not going to do all that, and we're just going to say not available when it comes to the to a special name for that angle pair. So now 125 minus 5 is 120. I just simplified the left side of the equation and subtract 120 from both sides, and you get 3x is equal to 60. Divide both sides by 3, and we get x is equal to 20. So we're done with those problems. All right, so now we're going on to converses of those things that we just learned. We learned the corresponding angles postulate and those three other theorems, but it turns out that the converse of those statements are true also. The converses are true also. So we're going to learn the corresponding angles converse postulate. The corresponding angles postulate, the original postulate we learned, says that if two lines are parallel, then corresponding angles are congruent. The converse of that says if corresponding angles are congruent, then the lines are parallel. That's the formal statement of it. Again, it's just very simple. It's just the converse. So it says here, use a two-column proof in the corresponding angles converse postulate to show that the lines below are parallel. So we're going to do this one together. And again, we're trying to show that these two lines are parallel. We don't know that they're parallel. In the previous problems, we assumed that they were parallel. Now that we don't know that they're parallel, we're trying to prove that they're parallel. So we're going to start out with the given information. We know that the measure of angle FEG is equal to 75 degrees, and we also know that the measure of angle ABC is 75 degrees. That is given in the diagram. Now, we know that the measure of angle FEG is equal to the measure of angle DEB. So in other words, this angle here is equal to this angle here, the measures. And how do we know that? Well, obviously that's just the vertical angles theorem. So notice here, FEG is 75, right? And FEG is DEB. So 75 and DEB are both equal to the same number. So that means they're equal to themselves. So the measure of angle DEB is equal to 75 by the transitive property of equality. So we now know that this angle, DEB, is equal to 75 degrees. But we also know that angle ABC is 75 degrees. So we can use the transitive property again. And by the way, we probably could have skipped this step, really, and just gone straight down to here using the transitive property of equality. Again, you can skip some of these steps when you get into these to upper math courses. Let's see here. So now we can use the transitive property of equality again to say that the measure of angle ABC is equal to the measure of angle DEB. And that's the transitive property of equality. So again, I just want to be clear, ABC is 75 and DEB is also 75. Therefore, ABC must be equal to DEB. So now that we know ABC we know is congruent or equal to, the measure of ABC is equal to the measure of DEB. So the big question is, who cares? Well, the reason we care is because we just learned the corresponding angle's converse postulate. So what that means is that if corresponding angles are congruent, that proves that the lines are parallel. So again, we're going backwards. So now we know that line, you can name these, you can give them different names based on the letters that you use, but I'm just going to say GD, line GD, is parallel to line BC. Remember that parallel symbol, two vertical lines to show that they're parallel. And that is, how do we know that? The corresponding angles converse postulate. And I guess I can write the actual word. So corresponding angles converse postulate. So again, we're doing the converse statements now. So this can get kind of confusing when you're going back and forth. So just go back to those original four statements, learn those, and then learn the converses. All right, so on to the next problem. As you can imagine, we came up with a postulate for the converse of the corresponding angle statement. So it turns out that we have the converse of the alternate exterior angles theorem is also true. So we come up with the alternate exterior angles converse theorem. So it says here, use a two-column proof and the corresponding angles converse postulate to prove that alternate exterior angles, or the alternate exterior angles converse theorem is true. All right, so we're going to assume that alternate exterior angles are congruent. So angle ABC is equal to angle HFG. Now you can choose these two, or you can choose these two. It doesn't really matter. I'm choosing ABC and HFG. So I'm just going to mark those. If those are congruent, then the lines AD and EG must be parallel. So we're assuming that the pink angles are congruent. That's given information. Again, we're trying to prove the alternate exterior angles converse theorem. So you might want to take a screenshot of that so you know exactly what we're trying to prove. So we assume that alternate exterior angles are congruent. We're going to show that the lines are parallel. Now, I know that measure of angle ABC, the measure of angle ABC is equal to the measure of angle FBD. That's just the vertical angles theorem. So obviously, if ABC is HFG and ABC is also FBD, you can see where I'm going with this. The measure of angle HFG must be equal to the measure of angle FBD. And that's the transitive property of equality. So HFG is equal to FBD. So what that means is that this angle is equal to this angle. So we just proved that corresponding angles are congruent, or we just proved that those corresponding angles are congruent. But by the converse of the corresponding angles postulate, the corresponding angles converse postulate, we know that those lines must be parallel. So AD is parallel to EG. All right, so again, we just proved the converse of the alternate exterior angles theorem. So now I want you to prove the converse of the alternate interior angles theorem. So if alternate interior angles formed by a transversal are congruent, then the lines cut by the transversal are parallel. Use a two-column proof and the corresponding angles converse postulate to prove the alternate interior angles converse theorem. I know that's kind of a mouthful of words there, but what that means is you can choose any pair of alternate interior angles. You can choose this pair, or you can choose this pair, but you want to show that you want to show that if those angles are congruent, then the lines AD and EG are parallel. So again, I'm going to get you started with the given information. So I'm just going to use these two pairs here, or that one pair. So the measure, we're assuming that the measure of angle ABF is equal to the measure of angle BFG. And that's given information. So now I want you to prove that if those peak angles are congruent, then AD must be parallel to EG. And you're going to use the corresponding angles converse postulate and also the vertical angles theorem. So try that problem, and when you come back, we'll do it together. All right, we're back. Now we know that the measure of angle ABF is equal to the measure of angle CBD. That's just the vertical angles theorem. So now, by the transitive property, we know that the measure of angle CBD is equal to the measure of angle BFG and because those measures are equal, again, I want to be clear, CBD is equal to BFG. So by the corresponding angles converse postulate, the line AD must be parallel to EG. Corresponding angles converse postulate. All right, now we're going to prove the converse of the consecutive interior angles theorem. And by the way, if you got that right, good job. Use a two-column proof and the corresponding angles converse postulate to prove the consecutive interior angles converse theorem. So in this case, we're assuming that consecutive interior angles are congruent. So we can just choose these two. You can choose these two if you want, but it doesn't really matter. Angle BFG and angle FBD are supplementary angles, and that is given. So we're going to show that if those angles are supplementary, then the lines AD and EG must be parallel. Now we know that these two form a linear pair. We can see that. So angle CBD and angle FBD form a linear pair. So CBD and FBD form a linear pair. And that's just given in the diagram. So now you can, by the linear pair postulate, if these form a linear pair, they must be supplementary. So angle CBD and angle FBD are supplementary angles. That's the linear pair postulate. So now, at this point, we can use a theorem to make this go faster. We learned how to do that in the last class. BFG and CBD are both supplementary to the same angle, FBD. So we can use the congruent supplements theorem. Angle BFG is congruent to angle CBD, and that is the congruent supplements theorem. So because BFG, now here's the important part, it's really important to know what we just did there. BFG we showed is congruent to CBD. But if they're congruent, by the corresponding angles converse postulate, lines AD and EG must be parallel. So AD is parallel to EG. Corresponding angles converse postulate. So if you got that answer, good job. All right, now we're going to go to some practice problems. Find x and y such that lines Q and R are parallel. You don't have to do a formal proof, but state the primary theorems or postulates used. So we want to know what value of x would make these lines Q and R parallel. Well, we know by the alternate interior angles converse theorem that if this angle is equal to this angle, then by that converse theorem, Q and R, the lines Q and R must be parallel. So this is an easy problem. We just say x is equal to 100 degrees. But we have to state the theorem that we used. We use the alternate interior angles converse theorem. This is not a formal proof. You don't have to do a formal proof, but we're just finding what x is, or what it has to be in order for those lines to be parallel, and then we're stating the basic principle we used to come to that conclusion. All right, so now 39. We have consecutive interior angles, and we know that if these two angles are supplementary, then by the consecutive interior angles converse theorem, that will make lines Q and R parallel. So we have to find the value of y that would make this angle supplementary to this angle. Now supplementary, that means that those two angles, 94 and y plus 10, they have to add up to 180. That's why I added them. I'm adding them together. And if you want, we can put parentheses around these so you can see what we're adding together, but you don't really need parentheses. 94 plus 10 is 104. And then we subtract 104 from both sides, and we get y is equal to 76. So in order for these lines Q and R to be parallel, y has to be 76. And we showed that. Let me move this over here. The principle we used was the consecutive interior angles converse theorem. All right. Attempt number 40. Again, we have to assume that those angles, those look like corresponding angles, so we're going to have to assume that those corresponding angles are congruent, because by the corresponding angles converse theorem, that proves that the lines Q and R are parallel. So go ahead and try number 40, and when you come back, we'll do it together. All right, those are corresponding angles, so we have to assume that they're equal, because that's the only way that we could make Q and R parallel. So subtract 4x from both sides, add 20 to both sides, and x is equal to 30, and that is the corresponding angles converse postulate. So if you got those answers, good job. Try number 41, and when you come back, we'll do it together. All right, we're back. X must be 87 by the alternate exterior angles converse theorem. It must be 87 in order for the Q and R to be parallel. So we have to assume that X is 87. And that proves by this theorem, the converse theorem, that Q and R are parallel. So if you got that answer, good job. All right, on to the next problems. Try number 42, and when you come back, we'll do it together. All right, we're back. So those are corresponding angles. So we know that y, we have to assume that y is equal to 140 degrees by the corresponding angles converse postulate. And that's pretty much it. Y has to be 140 in order for those two lines to be parallel by the corresponding angles converse postulate. So if you got those answers, good job. Try number 43. When you come back, we'll do it together. All right, we're back. Now these are consecutive interior angles. We have to assume that those angles are supplementary in order for Q and R to be parallel. So we have to find x, assuming that they're 101 and x are supplementary. So supplementary means they add up to 180. Subtract 101 from both sides, and you get 79. And by the way, I forgot to write the assumption for that. That's the consecutive interior angles converse theorem. So if you got that answer, good job. So that was the class today pretty much. Don't go before you get your homework. So let's just review what we did here. We learned about all the names for the special angle pairs, and we learned four things. One postulate, 3 theorems. Then we learned 4 converses, the 4 converses of those 4 things. We learned the converse of the postulate and the converse of the 3 theorems. And that was, again, that's the class today. It's about transversals through 2 lines. So now let's look at, let's go ahead and, why don't you take screenshots of all that work. And the 3rd and 4th page. And the next 2 pages. 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 So now let's look at the homework. Go ahead and get screenshots of this. And here's the answers for the first 6 problems. And next page, get a screenshot of that. And notice you have the answers as usual. If you don't check your answers, then you're just wasting your time. And a screenshot of the last page of the homework. Now remember, if you don't do your homework, you're going to learn nothing in this entire course. So get that homework done. Make sure to check all your answers, do it completely, correctly, neatly, and know where your homework is. Keep your homework in order, chronological order in your binder, and I look forward to seeing you in the next class.